we will start with the second part of getting a transfer function from state space model. Introduction, Leverrier algorithm, numerical examples. So, in previous part we have seen that in order to get the transfer function from a state space model, we have to calculate the inverse, and to calculate the inverse for higher order system is quite cumbersome. Now, here we want a method which can easily give the inverse of a given system matrix. Now, Leverrier has proposed that instead of determining the inverse or determinant or cofactors, we can calculate the inverse of a given system matrix by using the trace of a matrix. Trace means a sum of diagonal elements. So, that is the unique advantage of the method which is proposed by the Leverrier. So, here there are some advantages, see it. As the order of the system increases, the mathematical computation burden will also increase. Second, earlier the digital computer fails to determine Si minus A inverse because the Laplace operator S is a scalar. However, nowadays due to advanced software, it is possible to find the inverse of Si minus A. Third point, we need an approach where there is need to determine inverse without determining the adjoint and determinant. So, Leverrier algorithm is based on trace of the matrix, that is sum of diagonal elements. That is, Leverrier has proposed a method. We say that in order to calculate the inverse, there is no need to calculate the inverse, that is, no need to calculate the determinant, no need to calculate the cofactor, only simple the concept of diagonal elements you can get the inverse. So, that is the beauty of this Leverrier algorithm. That means, if I am taking this as A matrix equal to A11, A12, A21, A22. Now, the trace of this matrix trace equal to A11, A22. That is simple addition of the elements of a given matrix, we are getting the trace, and here in this method using this concept itself you can get the inverse of a given system matrix, and once we get the inverse we can easily get the transfer function from a given state space model. Now, we will see the procedure that how to get the transfer function by means of Leverrier algorithm. Now, this approach is based on trace of the matrix. Trace is equal to sum of diagonal elements. So, here A11, A12, A13 first row, A21, A22, A23 second row, A31, A32, A33 these are third row. So, this is a given matrix, this is matrix A. Now, trace of this sum of diagonal elements, that is diagonal elements are A11, A22, A33, this is the diagonal elements. So, here A11, A22, A33. Now, Si minus A inverse, that is written as adjoint of Si minus A divided by determinant of Si minus A, that is equal to P1 sh to n minus 1, P2 sh to n minus 2, P n minus 1 s Pn, and here sh to n, A1 sh to n minus 1, A of n minus 1 s An, and now here P1, P2, P of n minus 1 up to Pn are constant matrices. So, here the elements from P1 to Pn are the constant matrices, and A1 to An are the constant scalars. Now, the steps for obtaining Si minus A inverse. The first step, we write P1 equals to I, that is an identity matrix, that is the first step. That is how you get it. So, we write this P1, this first element equal to identity matrix. Now, A1 equals to minus trace of A, that is first element, that is in this case this P1 and A1 we have got, A1 equal to minus trace of A and P1 is nothing but the identity matrix. Now, this P2 equal to P1 into A, A1 into I, and A2 equal to minus 1 by 2 trace of P2 into A. So, we got P2, A2, and you will find that in this particular method there is no as such division, no need for any minors, simple multiplication and addition. We have got P2 and A2, P1 and A1 we have just P1 I have assumed I, and A1 we have got minus trace of A. Similarly, if you move further, P n minus 1 equal to P n minus 2 into A n minus 1 into I, and here P n, that is P n minus 1 into A n minus 1 into I, and similar to this we have got A n minus 1 equal to minus 1 n minus 1 trace of P n minus 1 into A, and A n equal to minus 1 by n trace P n into A. That means all the elements of P1, P2, Pn and A1, A2, A n minus 1, A n we will going to determine, and simply by multiplications and simple additions. So, we will see the example. So, we have taken the same example which we have taken earlier. So, x dot equal to Ax plus Bu, and what is the desired transfer function? My desired transfer function is P1s P2 S square A1s plus A2. This is required to be determined. Now, how to get the P1, how to get P2, how to get A1 and how to get A2. Now, P1 you just see the first step. P1 equals to I, that is identity matrix. So, you will find that this P1 we have taken as 1 0 0 1. Now, to get the A1, how do you get A1? This A1 equal to minus trace of A, that is trace of A. What is A? A means diagonal elements. So, that means here minus 0 minus 2, that is minus of minus 2 plus 2. So, we get that means we have got the trace of a matrix. Then step 2, this P2 equals to P1A into A1I. Now, what is P1? P1 is 1 0 0 1, A1 is 0 1 1 minus 2. What is A1? A1 into I, what is A1 we have got? A1 we have got 2. So, we write as 2 0 0 2, and after addition we get 2 1 minus 1 0. Now, to get A2, A2 equal to minus 1 by 2, just here step, that is minus 1 by n. So, here n is 2, 1 by 2 trace of P2 into A. So, minus 1 by 2 trace of 2 1 minus 1 0, A is 0 1 minus 2, and after multiplication of this one and a division of minus 1 by 2 we have got A2 equal to 1. Therefore, the desired inverse of matrix equal to P1s plus P2 S square plus A1s plus A2. So, we write the elements of all, that is P1 is the identity matrix. So, S0 0s, then P2 we have written. So, all these values we have written, and finally, you see here the transfer function is C SI inverse, that means S plus 2 1 minus 1s divided by S square plus 2s plus 1 0 1, and after solving this one, so we will find that it is after solving this we will get 1 0 1s, and about determinant we have got S square plus 2s plus 1, and finally we got 1 S square plus 2s plus 1. So, we will find that solving this example, simply we have done some multiplications as well as additions, and we have got the inverse, that means no need for any further calculations. Now, we try to solve another example which we have solved last time, and we will see whether we are getting the same result or not. So, we have taken the model x dot equal to Ax plus Bu, y equal to Cx plus Du. So, here if you write A as 0 1 0 0 0 1 minus 6 minus 11 minus 6, B equal to 0 0 1, and we have C that equal to 1 0 0. A B C we have written. Now, what is our first step? First step to get P1 and then A2 and like this. The first part is to get the P1. So, we write P1 equal to I, that is identity matrix, that is equal to 1 0 0 0 1 0 0 0 1. Now, we got P1. Now, to get A1, what is A1? A1 equal to the trace of the given matrix. What is the trace? Trace is here 0 0 minus 6, then minus 6 minus of this you will get 6. So, A1 equal to 6. Now to get P2, how to get P2? P2 equal to P1 into A plus A1 into I. So, we write P1 equal to 1 0 0 0 1 0 0 0 1, that is P1. A is 0 1 0 0 0 1 minus 6 minus 11 minus 6, and what is A1? A1 we got 6, so we can write down as 6 0 0 0 6 0 and 0 0 6. Now we have to multiply this and then add it. So after multiplication and addition, we will get result as 6 1 0 0 6 1 minus 6 minus 11 0. Now we have got P1 P2. Now we want A2. So A2 equals to minus 1 by 2 trace of P2 into A. So if you multiply it, we will get minus 1 by 2 trace of 6 1 0 0 6 1 minus 6 minus 11 0 multiplied by A is 0 1 0 0 0 1 minus 6 minus 11 minus 6. And now you have to multiply this, then taking the trace of this one and divide by minus 1 by 2, and after doing this one you can get result as 11. A2 will get at 11. So we have got P1, we have got P2, we have got A1, we have got A2. Now they need to calculate the P3 and A3. Now to get P3, this P3 equal to P2 into A plus A2 into I. Now what is the value of P2? This P2 equal to 0 6 1 minus 6 minus 11 0 0 minus 6 minus 11 P2 into A. Then this A2 into I, A2 is 11, I is the identity matrix, so we can write down as 11 0 0 0 11 0 0 0 11, and after addition of these two matrices we will get it as 11 6 1 minus 6 0 0 0 minus 6 0. Okay, we can write down as A3 equal to minus 1 by 3 trace of P3 into A. That gives you 6. So here we have determined P1, P2, P3, A1, A2, A3, and now this has to replace in this equation, and after replacing it we will get the same transformation model which we have got earlier, that is we will get transfer function GS as 1 upon S cube plus 6S square plus 11S plus 6. So in this way we have calculated the transfer function from the given state space model. Now these are some references. Thank you.